on. Before we go on to cyclotrons, we need to talk about something in the middle, and that is the concept of relativistic speed. So what relativistic speeds mean is basically some speed, any speed which is comparable to the speed of light. So what is the speed of light?
3 into 10 to the power 8.
Yeah, it's 3 times 10 to the power 8 meters per second. So we know this is the fastest speed possible, and according to Einstein's special theory of relativity, it is impossible for any mass to reach the speed of light or even, let alone exceed the speed of light. So based on this, if we were to take an electron and if we were to accelerate it across a certain potential difference, we could theoretically push it to the point where we actually exceed the energy required to reach the speed of light. How would we do that? We basically do half mv square is equal to qv, right? So given that our potential difference is large enough, linear accelerator potential it is technically possible to exceed the kinetic energy beyond this. So that would technically break Einstein's rule that you can't travel faster than the speed of light. We would actually have to revise our understanding of physics if that was true. So once we reach these velocities, what we tried to do is we tried disproving this. How did we try disproving it? By obviously accelerating small charges to velocities which should exceed the kinetic energy, right, of the speed of light. And we actually did take it to such kinetic energies, but we saw something really weird happen. Ki hoise is, if we draw a graph, but the kinetic energy increased proportionately, right? Kinetic energy. But what happened to the velocity is, the velocity did not exceed the speed of light. So if this is the speed of light, velocity ta barte emni to square rule follow korbe, but still it would approximate the speed of light, but it would never actually reach it. Even if you went like really fast. If you go and study about the Large Hadron Collider, which is the most powerful accelerator we have on Earth right now, it accelerates particles to almost the speed of light, but not exactly the speed of light, right? So the machines, the more powerful the machines come, the number of nines after, the point, it keeps increasing. By basically say 99.99999% the speed of light. But it
theoretically, so it's never possible to
it's practically not possible to reach 100% the speed of light. So how is it possible that tomar kinetic energy badteche but tomar velocity badteche na? There's only one possible explanation. As the particles move faster and faster and reach relativistic speeds, the mass of the particle increases, right?
Yep.
This starts to put everything into sense. Speed of barlo na, tomar speed of light tumi exceed korlo na, which is fine, and also tomar kinetic energy barite holo. Because you're giving it that potential, so it has to accelerate across that potential and absorb that energy and travel with that kinetic energy. So kinetic energy tiki badteche, that's okay. Kinetic energy tiki badteche, tarpor abar tomar momentum o badteche, shobi badteche, but the speed, the velocity of the particles never exceed the speed of light. So basically what happens, as you take particles to higher and higher speeds, higher and higher kinetic energies, and also closer to the speed of light, its mass increases. Right? So there's an increase in mass. Does this make sense? Yep. This is actually something which was also predicted by Einstein's special theory of relativity, that the faster you go, the mass of the particles progressively increase. Do you get that?
Yes.
So there's this small equation I'm just bold to see. It's one of the equations of relativity. Basically, the mass of a particle is equal to m naught, original mass when it's stationary, divided by root over 1 minus v square by c square. Right? So let's see what this equation actually means. C square is the speed of light. V square is the speed of the particle. So when you're stationary, then v square value koto? 0. So 1 minus 0 is what? 1. So root 1 is 1. So m is equal to m naught. Right? When v is equal to 0. As you start to approach the speed of light, what happens? The value of v increases, right? And at small value, when I throw a tennis ball at you or something like that, or a rock at your face, something like that, the value of v will be very small compared to the speed of light. It almost 1 thakbe. Do you get it? Because v squared by c squared is almost like 0.0000001. So it doesn't cause any change in mass. However, now if we go travel faster and faster, the value of v gets closer and closer to the value of c. Right?
Yep.
So imagine this. V squared by c squared value ki hobe? It will reach a greater and greater value. right? Closer and closer to 1. So 1 minus that is going to be a value less than 1. Right? So তখন কি ধরো m হয়ে যাবে at a certain speed m naught divided by 0.2. কথার কথা কেন? Because 1 minus that root করলে ধরো 0.2 আসলো। তখন কি what's going to happen? The mass, according to the equation, the mass will be more. Right?
Being divided by this.
Yeah, because speed partition. And then, at a point, we actually reach the speed of light, theoretically. This becomes c squared.
1 minus 0.
1 minus 1.
1 minus 1, which is 0.
Depends. So 1 minus 1 is 0. So m becomes what? M naught divided by 0, which is what? An incalculable amount of mass, right? So that would mean for an object of any mass, even if it's as light as an electron, if we were to accelerate it to 100% the speed of light, by then its mass would move to how much? Infinity, or almost infinity. Do you get it? So, it is practically not possible to make any mass travel faster than the speed of light, and obviously not even equal to the speed of light. Is this clear? So we'll need this concept to move forward with cyclotrons, because Linux can't do it. Most Linux can't do it, but cyclotrons can actually make charges accelerate to relativistic speeds. তখন গিয়ে we start seeing deviations in its behavior because of its mass or change in mass.
So Linux also speed যায় না দিলে?
Linux compared to cyclotrons, no.
So cyclotrons are more effective.
Yeah, they can actually accelerate particles to much higher energies. That 2% clear? All right, let's move forward.